at the center of the circle. These are inscribed angles. An inscribed angle is where the vertex is on the circle. We talked a little bit about that yesterday. Okay? So you need to be able to know the difference because how they relate to their arcs are different. Okay? A central angle is equal to its arc. However, an inscribed angle is half the measure of its arc. It's a lot further away. Right? Its arc, because it's so far away, its arc is a lot bigger. And so if the inscribed angle, which right here, let's say if this is 30, then this arc is 60. So if you're trying to find the angle, if they give you the arc, you have to divide it by 2 to get the angle. If they give you the angle, you have to multiply it by 2 to get the arc. Okay? Think about it, it's a lot further away, so it's a lot smaller. Okay, when you make an angle, the further out you go, the bigger the raise is. Okay, so an inscribed angle is half the measure of its arc. All right? That is basically going to be the basis of all of these problems. All right? So let's look at a couple of easy examples. Okay, you may not need to copy these down. Let's just make sure we understand the concept. So we have to find the measure of either the arc or the angle. Okay, so for this one, the angle is what? The angle is 90, the arc is 180. Very good. Okay. For this one, the angle is 115. What's the arc? 230. And for this one, the arc is 100. What's the angle? Okay, good. Now, we're going to talk about a few theorems that deal with inscribed angles. We're going to talk about one that's talking about an inscribed triangle and then an inscribed quadrilateral. Anybody know what inscribed means? What do you think it means? Inscribed means inside a circle. Okay? So these are things that are inside of a circle. They're inscribed. Okay? And so when I say an inscribed angle, it's an angle that's inside the circle. Okay? Now, one of the theorems, this is just a look ahead. Don't write this down, just listen. One of the theorems talks about, and you'll write the theorem down on the next page, talks about how if a side of an inscribed triangle is a diameter, then it's a right triangle. Okay. If a side of an inscribed triangle is a diameter, then it is a right triangle. Okay. Let's look at this figure right here. Okay. This is a theorem that they put as a kind of a fancy rule, but it's very logical. Okay. You should already be able to see this. If I made this, so let's say this is my center and that's my diameter. Okay. We saw that this arc was 180, right? That means the angle that created this arc has to be a diameter because it forms a semicircle, right? Its angle, the only way you get a 180-degree arc is if you have a 90-degree angle. Does that make sense? Okay, so that's all that theorem says. These theorems can logically make sense, okay, if you just think about what they mean. So let's look at the first inscribed angle theorem. And I'll let you copy this down and we'll talk about it. Okay. This inscribed angle theorem says if two inscribed angles of a circle, so you have two inscribed angles inside the same circle, if they intercept the same arc. Now, let's talk about the word intercept for a minute. First, I'm going to go back to this page. When we described an inscribed angle in this diagram, it says this is the angle and this is the intercepted arc. It just means that's the arc that that angle creates. Okay, intercept means you cross its path, right? So this angle intercepts this arc. It's just the terminology they use. It makes the arc. Okay, it's the angle creates that arc because it cuts through it. Okay, so let's go back to this. So it says if two inscribed angles of a circle intercept the same arc, then those angles are congruent. Well, that should make perfect sense because the angle and the arc it creates have a direct relationship, right? So if we're looking at angle C, that's right here. angle C, the arc that it creates is right here, arc AB, right? So if I have another angle in there, this angle D, that creates that exact same arc, those angles have to be the same. Does that make sense?
Yeah.
If this arc is 100 degrees, this angle has to be 50, and angle C also has to be 50, because they create the exact same arc. Now, you need this theorem because they may not give you what this arc is. All right? For example, they might say, this is 40. You don't know what this arc is, 40 degrees, but they'll say, what's angle C? Well, you have to know that that's 40 because of this theorem. So you have to, if you didn't know the theorem, you would have to logically see that they both create the same arc, so they have to be the same. Yes? If they create the same arc, yes. If you had another angle in here that created that same arc, it would also be congruent. That was a good question. Yeah, they have to be. Okay? Because whatever this is, half of it is the angle. So if they're on the same arc, they're the same angle. The angles have to be the same. Okay? The next one is an inscribed quadrilateral theorem. Okay? The third one we already talked about. So this is the only one that's really going to be kind of new information. Okay, this one says opposite angles of an inscribed quadrilateral are supplementary. Okay? This is not to be confused with parallelograms. Okay? This is just a quadrilateral. It's not a parallelogram. Because you know with parallelograms, opposite angles are congruent. This is not a parallelogram. This is just a lopsided, just a four-sided figure. Okay? If it's inscribed inside of a circle, the opposite angles are supplementary, which means they add up to equal 180. Okay? So if this is 100, this has to be 80. Okay? So if those were algebraic expressions, you would say this plus this equals 180. All right? Any questions? So I don't have a logical explanation for that. It just is what it is. Okay? The third one is the one we already talked about, the inscribed triangle theorem. And it says if one side of an inscribed triangle is a diameter, which is this in red, then it has to be a right triangle. And that's because that arc that it creates is 180 degrees. So that angle has to be 90. Okay, that's all that's saying. And we already talked about that. You would see that when you did this. Because this is a semicircle, so this is 180, so this has to be 90. Okay, these are some easy examples. Find the value of each variable, all right? So, when we look at figure A, what kind of triangle does it have to be?
Right.
It has to be a right triangle because my diameter is here, which means this forms, its arc is 180, so this has to be 90. So you'd say 2x equals 90, so x equals 45. Well, just 45. No. The next example you will need to write down. This is just concept understanding, okay? Now, for B, what do we see inside that circle? A quadrilateral. The theorem that involved your quadrilateral says that what? Opposite. Opposite angles are supplementary. Okay? Opposite angles are supplementary. Supplementary means they add up to equal 180. So, these two are supplementary, and these. So if this is 120, what does y have to be? 60. Okay? And these two are supplementary. So if angle F is 80, angle Z has to be 100. Okay, everybody understand? Yeah. Now that is those theorems in their simplest form. No. Okay, so this is, these are the tools you need to work these problems. However, these figures are not as simplistic as these. Okay? what I do is you need to have some sort of way for you to mark on your page when you have these figures, for you to keep straight in your mind what angle creates what arc. Because you're either going to be multiplying 2 times that angle to equal the arc. And remember those problems like last night's homework, they're kind of like a scavenger hunt. You've got to figure out, sometimes you have to figure out what all the arcs equal and then add some of them together to find what they're asking you to do. Okay? So let's look at a couple of examples. These are a couple of examples like your homework, like the homework I'm going to give you. Okay? So they give us this angle. It creates this whole arc here, right? Okay. So if this is 92, the arc has to be double that, right? This one just happens to be exactly half, but 92 times 2, right, is what the arc would be. And so 92 times 2 is 184, right? And then if you needed to figure out what this piece is, it also has to be 92. Because if you do 184 minus this, it gives you TK, right? And so we're trying to figure out what, here's the angle that we need. It creates this arc. Okay, so we actually didn't even need to find anything. It creates this arc. So, oh yeah, we did. Yeah, we did. So we need this angle here. So we need to know what this arc is. Once we know what this arc is, we can divide it by 2 and get that, right? Okay. And so we know that this plus this plus this plus this has to equal what?
360.
360. Okay? So once we know what this is, then we can add these 2 and divide it by 2 to get that. Who did I lose? Did I lose anybody? That's why I said it's kind of like a scavenger hunt. You gotta use those angles to figure out what the arcs are, to figure out the missing pieces for the arcs. Okay?
Yeah.
Okay, so 360 minus 70 minus 92 minus 92 equals, what's left will be that other arc.
106.
Okay. Y'all second and third that?
I said 106.
That's not 106.
Okay, 360, so I'll do it. Minus 70 minus 92 minus 92 is 106. So this piece right here is 106. Right? Y'all see what I'm saying?
Smart.
Okay. So what we need to do is add 106 plus 92, right? 106 plus 92 is 198, and then divide that by 2, and we'll have our angle. What is it?
99.
So this is 99. Because this whole thing is 198.
Why are the 2
It just says something.
Yep. Okay, so if you double 69, you get this arc. 69 times 2. Okay, all the way around is 360, right? So 360 minus 145 minus 138 equals 77. Any questions? We good? Y'all ready? Let's do 3 and 4. Okay, there's 2 different ways you can work number 1. Okay? First, if you recognize that this is a triangle that the diameter is one side, that makes this what?
90.
That makes that a 90-degree angle.
Oh my God.
So if I didn't recognize that at first, so that is but if you did, then that makes the problem easier. Because if this is 60, this has to be 30. And if this is 30, this has to be 60. So 10x equals 60, x equals 6. Okay? That was not the route I took the first time, but that is much easier. The route I took, you don't understand this? Okay, this is an inscribed triangle where a diameter is one side, so this has to be a 90-degree angle. So if this is 60, this has to be 30, right?
Okay.
So this angle, this 30-degree angle, creates this arc. So if this is 30, the arc has to be 60. So 10x equals 60. Okay, so that was one way to work it. The other way was to recognize that if this is 60, this arc here has to be 120, right? Yeah? Now, both of these together equal 180. So 10x plus 120 equals 180. And you still end up with 10x equals 60 and x equals 6. That was how I worked it the first time. It is easier to do it if you recognize that this was a 90-degree angle. Okay, but either way is correct. Any questions? Are y'all done with number 2? I mean number 4?
Yes.
No?
No, wait, no.
Wait, what's the four now?
Yes, y'all can do number 4 if you haven't already. Okay, so you should have gotten x equals 4. Okay, so I always go from the angle they gave me to figure out the arc. So 2 times this equals that. So 2 times 16x plus 4 equals 20x plus 15x minus 4. So 32x plus 8 equals 35x. 20x plus 15x is 35x minus 4. Subtract 32 from both sides, and you get 3x over here. Add 4 to both sides. That becomes 12, so x equals 4. Easy peasy, right? Okay, so we have to write both equations, and then we're going to have 2 equations and 2 unknowns. And then we have to solve that system of equations using, I would use elimination. You can use substitution or you can use elimination. I find elimination easier, especially when one of the variables is already just about set up for you. Okay, so what does this look like? Let's do the red one first. So 12x plus 7 plus 12y minus 7 equals 180. Okay? I'm going to put that in standard form. So that's 12x plus 12y. My 7's just happen to cancel. So equals 180. So that's standard form. Now let's do the other ones, the blue ones. So 12x minus 3 plus 13y minus 5 equals 180. So now I'm going to put that one in standard form. So I have 12x plus 13y, and then I have 180 plus 5, and then plus 3, right? So it's 188. So I add 3 to both, and then add 5 to both sides. So here are my two equations with my two unknown variables. So we're going to solve that system. So I have 12x plus 12y equals 180. And then I have 12x plus 13y equals 188. To solve a system of equations using elimination, you want to eliminate one of your variables so you can solve for the other one, and then go back and plug it back in. Okay? And so I could cancel my 12s if one of them was negative. So I can multiply either the top or the bottom by -1. Right? So the top, okay. So we'll multiply the top by -1. So now this becomes negative 12x minus 12y equals -180. Mathematically, that's legal as long as I do it all the way to every term, right?
Yeah.
Okay. So my bottom I didn't change. 12x plus 13y equals 188. Now my x's cancel. When I combine them, this becomes y equals 8. So I solved for y.
Good.
So I just go back and plug it in and figure out what 8 is. Well, I mean, what x is. Yes.
So, is it like mathematically illegal to just subtract the
That's doing the exact same thing. If you subtract this equation, you're multiplying that bottom by -1. That's it's and you'll get the exact same result. Yes.
I have a question. Would you?
Okay. So now we have what y is. Now we go back and find x by plugging it back in to either one of our equations. So we have y, go back and find x. So I have 12x plus 12y equals 180. So 12x plus 12 times 8 equals 180. So 12x plus what? 96 equals 180. So 12x equals 84. And x equals 7. Yay! Okay, so my answer is x equals 7 and y equals 8. That was fun, wasn't it? Okay, I'm going to give you your worksheet now.